Hello, everyone. It's Steve with Aptera Owners Club. There was a special Aptera Owners Club only tour of the factory and the offices by Chris Anthony. This was coordinated by Audra from Aptera and Emor, one of our members. And I believe this is some of the most interesting stuff to come out of EVA 2024. So here's the first part of that tour.
We're that much closer to the entire billionaire every time I like to watch this. I've met with several billionaires and we haven't inspired anybody yet, but we're getting really close to a debt deal. I think we'll have a debt deal in a couple weeks here, and then I think an equity deal will follow behind that. And our crowdfunding is still doing gangbusters. We only got 100 spots left in the accelerator program. 98 now?
98, you crossed it.
They're going quick. But we could continue the crowdfunding and get into production. It just happens really slowly, and we don't want to wait. We want to get vehicles out as quickly as possible. So, our burns, pretty low. It's 1.2-ish million a month. So if we raise $6 million a month with the crowdfunding, $4 to $5 million every month you can spend on tooling and equipment. But if you pace that out, we won't have all the tooling and equipment for like another year plus. So we would rather get some debt in and get some equity dollars in and a little bigger raise, but our story is stronger than ever. So it's only money in the bank. We got great strategic relationships. We got a vehicle that's ready to be produced. So
what's the
things that are happening
after the accelerator program closes?
What's the crowdfunding idea?
Well, so the accelerator
It'll still
program.
keep going. Yeah. So we still have that $2,000 investment thing. So if we invest $2,000 coupons. And the regular crowdfunding, that's been good for like $1.5 million, $2 million a month, just without advertising or anything, just people coming to the website.
Would it be like accelerator style?
No, I don't think so. Yeah. No, I think we've blown our wad with the accelerator program, and that's it was a good program. It was
don't do it again.
It was mildly inspired by the Sono guys. When the Sono guys did their program to try to save their company. Everybody came to us and like, can't we just put a deposit down on a vehicle, something like that? I was like, well, California has really strict rules. If you give us a deposit for your vehicle, we can only spend it on the parts to build your vehicle. And so the money's basically worthless to us until we're in production. So the accelerator program was a good mix of, okay, now you get something for your investment, you get one of the first 2,000 vehicles, and it helps us get to production quicker. So, but I don't think we could open like another 1,000 slots. I think it would be disingenuous. Piss a lot of people off.
Not as an extension of the original one.
Yeah, not as an
extension. It wouldn't make me happy.
Yeah. I could see something like, opening up some spots to $1 million guys. Like, we're going to open up 20 spots. You got $1 million and you want 20 spots?
You know what? I'd like those guys in front of me in a heartbeat.
That's fine.
I think we'd all forgive that.
Yeah.
But nothing's on the table now. Let's start over in electrical engineering. You guys can ask questions.
Is there anything we can't film in here?
I've had film.
Okay, we can.
Yeah, I would say you could film. Just don't take close-up pictures of the actual materials that we have in solar. So like,
so I'd like pictures of robots. That's still
yeah.
Chris, about
Hey,
investing,
we're under 100.
I think you get about a dozen PI vehicles out on the road.
Yeah, and then investing will be.
Then it becomes real. Nobody can say it's not real at that point.
Yeah, I agree. Also, fleet orders. A lot of the fleets just want to see the real thing that we're going to deliver. So, we've got talks with Disney and Uber Eats and a lot of big fleets, but they don't want to see prototypes. They want to see what you'd actually buy. So.
PI is close enough.
Yeah. Here, we can show them that.
Oh yeah, we saw a video of this.
They'll take a picture of the circuit boards.
Yeah.
So this is a typical wiring harness from an electric vehicle.
Oh no.
Typical wiring harness.
All of that for a single car.
For a single car. Yeah, this is a small electric vehicle of Asian descent. But this is, in the 40 to 60 pound range.
Yeah.
Copper's heavy. What we do is we do a distributed I/O system, a control board. So we have a head end called our Aptera gateway module. It communicates with these point of use controllers, and the point of use controllers exist close to the devices that they control. It's like we have one in the back for the tail lights, and we have one in the dash for the HVAC and some of the controls there. But to do that, we only need a power, ground, and a communication wire. So that reduces our wiring harness weight by like 2/3. So we've saved 40-ish pounds on our wiring harness just by going with this. And the components on circuit boards and microcontrollers and such are very reliable now, kind of through the charts on reliability. The number one failure in new vehicles is connectors. So if you can get rid of as many connectors as possible, you're just going to have a more robust vehicle build. So the only 3 buttons on the Aptera are the 2 buttons to open the doors and the hazard button. And the hazard button is a requirement by law. So everything else is digital. It's on your screen. We do have a backup Prindle that's underneath in case the screen totally fails or the computer's messed up. There's a safety communications layer that exists even if the infotainment computer's down. So you can still do park, reverse, neutral drive in that in case everything goes haywire. But all this is developed ourselves. We roll all our own boards, and we're very proud to be able to have such a robust and lightweight I/O system.
Is that electric power steering?
Oh yeah. Electric power steering, tilt but not telescoping in production, and obviously compliant for our future needs for ADAS and autonomous driving.
Is drive-by-wire on the?
No, not for us. It's cool, but it's not commoditized yet.
Gotcha.
So it's kind of like Tesla's 48-volt system. It's cool. We'd love to adopt it, but it takes a lot of money to get in that game.
Yeah.
Same thing with steer-by-wire. Canoe, Lexus, and Tesla.
I think even with that system, if it was 48 volts, it wouldn't save that much.
Yeah, we'd gain another. We'd lose another like 5 pounds is what we figured, 5 or 6 pounds.
At what cost?
Yeah. So it's like a big turkey dinner. If we just tell people not to eat too much turkey. Here we'll go over see the simulation now because that kind of shows you an overview of the whole factory, which is cool.
Yes. Yeah. That's up this one.
There's
This one.
but there's the left and right.
Yeah.
Side here, but there's no.
Every 30 pounds of weight I add to the Aptera.
I love it. I never look down. I always got around the road.
32, but around. So this is really cool. We're a very data-driven company. This is my 8th startup. There are a lot of startups. I've done it a lot of different ways. But being a data-driven company really does pay dividends. So we have digital tools from Dassault. CATIA is our design software tool. We roll from our digital design tools into product life management. So that manages the evolution of the design. That product life management kind of issues out work orders and build orders to our enterprise resource planning software, which is NetSuite. We actually pull our financials and stuff out of NetSuite, issue all our POs and stuff. It's all in a very automated way. That's helped us to become not only PCAOB audit compliant, but also SOX compliant, which will help us become a public company in the future. Then out of the ERP system, you roll into our manufacturing execution system, which is Interratio. And this is actually us building, maybe it glitched. This is actually simulating our build of the full vehicle through our manufacturing execution system in a virtual environment. So before we're actually building physical vehicles, we're testing and stressing our manufacturing execution system by virtually pulling parts out of inventory, issuing them to the different build stations, and then consuming them to a finished vehicle that would be delivered to you guys. And we'll have traceability on the serial numbers of the parts, down to the individual battery cell level, the torque of every major bolt in the vehicle. So we know, hey, maybe our torque setting was wrong for some subset of vehicles, and we just have to go back and retorque some screws or something. And serial numbers of tires and safety components and stuff, so we can know, in the future if something goes wrong, where that is traced back to. This is also a cool visual of how the vehicle's built. So the battery pack is kind of the keystone of the vehicle. It's the heaviest item in the vehicle. So it's really the heart of everything that happens on the manufacturing side. It's battery pack, it's rear suspension, it's front suspension and body, HVAC, interior trim, coolant, blah, 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 hatches, fill it with fluid, honk the horn, drive it out the door to a great Aptera owner in the future.
Is this up to date with the current plan for what's coming off the boat from CPC?
This is not. So, a lot of this could happen at CPC, and we may change the order of the build. So we may get the full roller with the wheels on it, and then have to put the battery pack in at a later stage. So, up to 60 to 70% of this work may happen in Italy to start. And then once we bring that manufacturing equipment here, then we would start to issue parts to the assembly line like we see here. We'd build a body structure down the street and then deliver a body structure that would go on the battery pack and go through this. But this is kind of the optimal way that we feel is the most lean manufacturable way to build vehicles.
And will CPC be mimicking the same process with the Red Viking AGVs and so on?
No, they'll do it in a much different way because they're just responsible for the roller. So they already have ways that they build all these amazing supercars, and they're good at what they do. So we're not trying to change how they do it.
But the CPC, instead of shipping stacks of parts, they ship the entire thing.
Yeah.
So can they ship as many as 40 a day?
Oh yeah.
Can you guys?
It's about 8 in a sea container, so you would get 5 sea containers a day.
So they roll into a container, or do they get placed?
They're keyed into a stackable thing. So
the logistics of getting 40 per day out of Italy, you're comfortable with that?
yes.
Okay, cool.
In the beginning, you'll have to fly some over, which is going to suck. But
When
after
you
a while,
say rolling chassis, that's on final tires?
it may or may not be on tires. Obviously it's easier to kind of move around if it's on tires.
I
People
was
can move
assuming
it.
dollies, but then you talked about rolling chassis, so we're going to try to figure out how.
Yeah, it could be without the battery pack. There's a simple dolly with some caster wheels on it that sits with the vehicle. The problem with that is then you got to get it back to Italy, or you're throwing it away. So the tires are kind of a work between. I have seen places where they put no tires, but they basically put a caster wheel on each tire. So you put it on the knuckle. So you drive it around in something that's like wheels, but it's not wheels. So it could be any combination of those.
Easier to ship that back.
Yeah, maybe.
So does that mean that the Alafe motors will be being attached in Italy, or will by wheels you mean just wheels?
Yeah, likely it will come to us with the Alafe motors from Italy.
And then for the CTNS partnership, I believe you said you're forming like a joint venture, or like a joint company with them. Is that same thing going to happen with CPC, where it's like you're both investing into like one entity, or are they
Possibly.
Possibly.
The CTNS thing, you got to manage the cash of how you build inventory up too. So, we're buying a lot of battery cells. It's a big commodity game. How do you shuffle that cash? It seemed apparent that the easiest thing to do would be to form a separate company that can then get government grants and other things to funnel that cash into battery packs, and then we basically buy the battery packs from that joint venture. So there's a lot of fun tax and money shuffling things that go on there that is probably above my pay grade.
And they are interested in breaking into the American market by starting an assembly line.
Yeah, to be quite frank, America's where the growth is. We've got better demographics. We've got a much bigger, robust economy, and we're kind of the world is consuming a lot of technologies from America. So yeah, being in America is a great play for CTNS.
If that new company, would that new company only deliver to Aptera, or eventually also to?
No, we're talking about other clients right now.
And if that generates money, is that money that can go into Aptera, or is that money that goes off to Korea? Or?
We would be co-owners of the entity. So we would have to decide: is this a group that the joint venture facilitates the program? Like, is the engineering going to exist with the joint venture? And then a big trucking company says, I want to buy batteries from you guys. And then the joint venture is the one that does all the engineering back and forth, and the engineering company makes money. Or do they just buy what Aptera has already designed? If they buy what we've already designed, which is a 60-volt module that can be stacked however you want, then Aptera would make the money, right? Because we already designed it. So there's a lot of nuance to that, but I think the joint venture is infinitely beneficial to us. It'll have a lot of equipment and capital, so it's a real asset to us. Sandy Monroe and the Monroe team helped us, design the assembly stations, how many people are in those assembly stations, how the inventory is consumed, and then we did this animation our great marketing team here and Jake put this together from the data that Sandy Monroe gave to us, and Monroe and Associates. But we split this facility into vehicle assembly, battery assembly basically here, and solar assembly on the other side over there. So it's really all the inventory is consumed from those back shelves back there, and it either comes to the battery line or the solar line, and then the vehicles are assembled around the perimeter. So that's how the factory's set up. And with this factory, we can do about 40 vehicles per shift. And then if we want to run 2 shifts, we can do 80 vehicles a day. And 80 vehicles a day is about 20,000 vehicles a year. The logistics of this building kind of suck. If you wanted to do maybe 3 shifts, you could try, but you need better ways for trucks to come in and get Aptera and take them out. And the land and property around here and the way trucks get in and out is not the best. So we think that 2 shifts is probably the max that we could do here. But if we wanted to duplicate this factory in, say, San Francisco or Texas or Virginia or the Netherlands or Germany or Spain, Australia, we would find a better property that has better logistics, and maybe we could get that closer to 30,000 vehicles a year out of one facility, just like this, 100,000 square feet anywhere in the world. And that's the idea. We aspire to open 8 of these types of factories around the world by 2028 and be producing about 150,000 vehicles a year by 2030-ish. We aspire to deliver 1 million Aptera by 2033.
So on this property, you're talking about 40 vehicles a day with 1 shift.
Yep.
With that many cars exiting the overhead door a day, how much of a local buffer do you need for vehicles outside of the building? Or do you expect car carriers to come and sweep them away right away?
Yeah, we don't expect to have more than 200 vehicles at any one time.
And you've got enough parking lot area to
yeah, we've got 380 spaces, but obviously if the trucks, I ran into this in my boat company. We were building 7,000-ish boats a year. You can't stack up inventory for a week.
No.
Like it just gets to be a nightmare.
Yeah.
You got to get the trucks in. You got to get.
But you don't have just-in-time delivery necessarily. So someplace you got to have a buffer, right?
Yep. We would probably get another lot somewhere if we needed some sort of buffer. And eventually, you could say that the vehicles will be wrapped with their color at the end of line. We talked about, okay, well, this will just be assembly, and then the test drive where you kind of burn the vehicle in will be some loop. You drive it 3 miles around a loop, and then you take it to some other building. That's where they wrap it. That's where they clean it. That's where it gets ready. Maybe it's shrink wrap if it's going far away. Yeah, that's when it gets put on a truck and then shipped somewhere. We do hope that a lot of people take the pilgrimage here, because we have such extreme range. You can drive down from Seattle and you can pick up your beautiful launch edition Aptera, and 2 charges later you're back home. So it's a really cool idea for people to come here and get the experience, and we can teach how to use your vehicle and stuff.
Certainly hope to do that. That's great that we can talk about those logistics at this stage. Right? So much of the design has been buttoned down. It's amazing.
It's been a long road, but at least we're talking about it now.
There is one more. The solar panels, you said 10 a day currently, right? So you have to double or triple
10 panels a day. So yeah, we need 5 times the amount of equipment that we have here.
So you have the right equipment, you just need more of it, or you're designing something?
We have the right equipment here, we just need more of it, yes.
Okay.
Do we have any solar?
I don't know if I missed it in the animation, but I did see a lot of industrial robots. Is that something you expect to automate some of the process, some of the assembly process?
Yeah, we don't want to do too much of the assembly process in an automated fashion until we're really used to doing it by hand. And I think that Elon
So that's down the road.
Make sure you have the process perfected before you try to roboticize it, or you just be wasting money. Great pictures of early Tesla factory fun, where you've got a big robot that's supposed to be doing a lot of work. Then you have 3 technicians in the robotic thing doing all the work, and the robot's just sitting there doing nothing because it wasn't programmed perfectly or didn't have the right effector arm, or it doesn't assemble it right. So we don't want to fall into that trap where we spend $1 million on an assembly cell and then we have technicians doing all the work because it wasn't perfected.
I was just up at the Ford F-150 plant this summer, and I was noticing a lot of their robots had the the assembler on a seat that would just swing them into the vehicle,
Yeah,
swing them
yeah.
out, grab a part, swing into the next vehicle. You know, just to automate that part so your assemblers weren't.
Yeah, you know, we build a lot in subassembly, so it won't look like a traditional automotive plant. One of the big things is that, you know, a traditional automotive plant, they're taking the blank steel, they're punching them into steel panels, they're welding them together. A lot of the automation you see is how do you get that body structure together. We don't have any of that. All the parts are human positionable, they're very lightweight, there's only 6 of them. So a lot of the things you see in traditional automotive, we don't have. The paint shop is a huge part of a traditional automotive plant. A paint shop can account for almost half of your capex for a new automotive plant, and it produces 80% of the emissions of that plant. So we get rid of the paint shop. We just vinyl wrap our parts, which he's got a part down there you can show you. Let's talk about solar first. So these are solar cells. They're really cool. They're flexible solar cells, but this is a monocrystalline cell. So it's really cool that flat 50 micron piece of solar can flex this much. More importantly, it's held by this IBC matrix on the back, so it's a little copper matrix on the back that holds the cell together. That gives it a little more flexibility to where we can flex it on the tips. Lots of things like to flex in 2D very easily. Not many things like to flex on 2 axes. But this we can flex about 1.5 millimeters on each corner, and that gives us enough curvature to be able to go over our roof structure and stuff like that. Another cool thing is this copper matrix on the back helps if you crack or shatter a cell. The cell's still held together, so this is still producing power. So the old types of solar cells, once you did that, they were dead. Any micro cracking, any cracking of the cell, and it's gone. But these cells are very kind of fault tolerant. You want to hold some of the solar cells.
And you know, we were talking about this particular technology, the biaxial shape. Is there a future for going more than 1 millimeter per corner? Getting more curvature out of it? I mean,
yes, if you have the curve consistent, but you need to barrel out the shape more if you're going to do much more than 1.5 millimeters. The problem is that expansion and contraction will cause micro cracking in those cells over time if you go too harsh on the curvature. So we have areas of the vehicle that have more curvature than that, and we just don't put cells there.
Right, and that's what I'm getting at. It's like, what's the future of being able to go to?
The future is like a perovskite cell or some cell that coats the whole surface. Instead of using individual cells like this and stacking them in series, you would coat the whole surface.
It's like heavy foil.
Right past another cell.
Way thinner than I thought.
So that's a new cell. Yeah, all the solar cells on the vehicle are less than 6 pounds. So the solar does not add a lot of weight to the
You're
vehicle.
just talking about the cells, not copper between.
The cells and the whole cell assembly is about 6 pounds. How we encapsulate them and put them into a panel weighs more. But if you're just looking at, okay, well, what weight do you really add to the vehicle? Just to add the solar cells is not that much weight. 6 pounds. This is one of our early roof panels. This is done in much heavier glass, but it was just showing out some of the forming techniques. This is the new kind of glass that's much thinner, and this is the actual production glass that I showed you earlier, which is crazy to think that you get that much flexibility out of a panel, but you can pick this one up and feel it with your finger.
So the glass is more flexible than panels.
The glass is very flexible. It's not more flexible than polymer, but it's the glass is way more flexible than the cells.
Yeah,
I noticed the traces are gone with the production one.
Yeah, you can mask the traces. This is just a demo, so they didn't actually put the traces in, but I can show you on the machine down here. They can actually put a piece of tape over them so you don't see them.
Will they be produced with or without the visible traces?
We think it'll be produced with the visible traces.
Yeah, and we kind of like that.
Everybody, half people do half.
They'll probably be nickel coated bus bars too, so they'll be silverish
I
color.
guess this is a yoke sort of situation.
Well, you know what? I can live with the yoke, but the traces, half the people.
I don't know if you guys got the carbon fiber SMC part, but this is glass SMC part. So this is what will be on the exterior body.
This is the glass.
Vehicle. This is glass SMC.
Okay, so this is more flexible than
More flexible, but this is how we actually coat the vehicle. So the vinyl wrap that we put on the vehicle, we've had test panels out there for over a year with this vinyl wrap, and we found we don't have to treat the surface at all. We don't have to even clean the surface. Right out of the mold, we can put this wrap on. It's air permeable, so it doesn't trap bubbles and stuff, and it just works. So
without giving up information, do you have a supplier for the wrap?
we do, yeah. several suppliers, and there's different grades of wrap. There's paint protection film and it's regular vinyl, but 3M, Avery, and there's a third one. I can't remember what the third one's called. Anyways, there's lots of different wraps, and once we have the cut pattern, you can have the cut pattern cut out of any material you want. So if you want Barbie pink, which I'm sure you're in love with, you
big
can have
time.
Barbie pink. Or if you want your Gucci, you can get your Gucci print or whatever.
You've seen the Cybertrucks; everyone is wrapping them different colors. It's kind of cool.
How much time is involved with wrapping a vehicle?
2 people can wrap a vehicle in about an hour.
Unwrapping.
Unwrapping takes longer.
So it's like
leave it out on a really hot day, and then get an air gun and pull it off.
2 man-hours for a vehicle.
2 man-hours per vehicle. In the factory, it will take less because we'll have tools for people to use. But if you went to like your local shop, and they were like, I don't know how to wrap this thing. They'd probably do a video. You'd probably send them a video link from us where we'd show them how to do it. But we'd send you the cut pattern. They'd have all the cut patterns, and if you have the cut pattern, it doesn't take that long to wrap.
I'm surprised. That's amazing.
What takes long in custom wrapping vehicles is they don't have the cut pattern, so they have to just take the big sheets and they have to plaster it on, and it's kind of it's
10-year life expectancy.
10-year life expectancy.
That's what you said before, I think.
3-year maintenance schedule. So after 3 or 4 years, you're probably gonna look at some edge peeling. So you're gonna have to go back through, clean the edges. You might have to put an edge sealer in some places. But we expect kind of 3 to 5 years. You'll have to touch it up. But 10 years for sure.
Do you have any idea what it costs to rewrap 10 years from now?
It's about $400 in material and then the labor. So.
Wow, okay. Once again, way off.
It could get
my
cheaper
guess.
as wraps get more popular.
Sure.
But I would consider if you're buying it retail somewhere, $500 for the
That's
material.
a real viable option.
If you take it to a shop, they're probably going to charge you several $100s.
Well, yeah.
To get it wrapped. We've been saying $1,500, but I think it'll be cheaper. You guys saw the battery cells, but maybe something worth noting.
We got about 10 minutes.
Yeah, we got to start moving.
1, 2, 3, 4, 5, 6 battery modules in our battery pack. This is one of the modules that's already wire bonded together. The 45 kilowatt hour pack is our standard module like that. And the 23 kilowatt hour pack is just some of the cells in the parallel groups are taken out there.
I'm not that strong either.
Just fine.
We'll be after a couple of these.
It's the heaviest part of the car.
So this one is 90 millimeter tall cells, and this one is 120 millimeter tall cells. But that keeps all the same power busing. It keeps all the same PDU. It keeps the same battery management computer. It keeps all that the same. This is an example of the battery management computer. It's obviously a 3D print, but the battery management computer goes on each module, and then it communicates to a head-end board. They don't have the head-end board out here, but the head-end board is what makes all the decisions about how the pack is managed. Every battery pack fire that you've heard of in the news is caused by this guy. This computer didn't make the appropriate decision on what was happening in the pack, and it let it go rogue.
But that's an Aptera
there's
design.
Yours
There's
is
an Aptera
proprietary.
design.
There's firmware on that, right?
Oh yeah.
So you're going to be able to update it as you get smarter.
So my other company, Flux Power, is a lithium battery company down the street. They're the #1 supplier to the forklift industry. They sell lithium batteries. But I started that company on the back of a battery management computer I designed, and obviously I've been in the battery industry for a decade.
Technology you personally have brought to Aptera.
This guy.
Okay.
and the composite stuff. I'm the composite guy. So.
Chris,
and the computational theory.
rough ETA on the 120 millimeter cells.
Actually, they have them in Asia. We don't have them here yet.
So
Okay, so they're already being made.
Yeah, they're producing them now in volume. So they've already gone through all their manufacturing testing. Now we haven't characterized them ourselves yet, though. So
very cool.
I would think we're going to get them in probably another month or two. But it's kind of low on our priority list.
Do you know who the cell manufacturer is going to be, or is it going to be kind of whoever CTNS decides is best, like Samsung,
It's
LG?
not made publicly available, but it's cool.